Yeah. Good day, everyone. How's everything? Welcome to the first phase of our virtual class. And this class is going to be for SS1 students. And I'll be talking about chemical combination. Normally, you might have heard of chemical combination before, but this class is just to improve your knowledge and enhance more understanding on the topic. That's why we'll be having a virtual class. So now I'll be talking about chemical combination. Chemical combination. Now before we go into chemical combination, we've all heard of atoms, elements, compounds, molecules, etc. Right? We know what element is, we know what compound is, we know what molecule is. So that brings us to what we call chemical combination. Now, talking of elements, we have some elements that are stable. We have some elements that are unstable. That's what brings us to what we call chemical combination. Example of stable elements are helium. We have helium, we have krypton, we have argon. We call all these elements, they are all gases. They are gases. And we call them the what? The noble gases. And they have a valence. They have a valency of 0. That is, they don't have a valence number. And the reason why they don't have a valence number is because what? They are stable. Their outermost electron has been filled. All their outermost electron has been filled. For an element to be stable, its outermost electron must either be duplet or octet. That is, it must contain 2 electrons in its outermost shell, or it must contain 8 electrons in its outermost shell. So now, since all these are stable, only the noble gases are stable. Only the noble gases are stable, and they are what we call them group O or group 8 of the elements in the periodic table, and their family name are what? Noble gases. When you get to higher chemistry class, you understand more of periodic table, and probably this time as well we might do periodic table. So that's that. Now, since all these ones are stable, they cannot combine with other elements. Helium will never combine with another element. Argon will never combine with another element. As well as we have neon as well. Neon will never combine with another element because they are stable. They cannot collect and they cannot give. Before an element can combine with another element, it must be able to donate electron, or it must be able to accept electron. So all these gases that I mentioned here, they cannot collect electron and they cannot give electron. That's why they are stable. They don't combine. Now, other elements are unstable. For example, sodium, which is unstable. Potassium, which is unstable. Chlorine is unstable. Fluorine is unstable. Oxygen is unstable. Carbon is unstable. Other elements are unstable. That is, what I mean by they are unstable is that what? Their outermost shell. When I say outermost shell, it means the last shell. For example, when I say outermost shell, let's look at neon. From hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. You can see that neon is what? Number 10. Right? And from electron configuration, we have what we call the KLMN shell. The first shell can take just 2 electrons. The second shell can take just 8 electrons. If you look at this, 2 plus 8, 10, which already has been completed. So you can see that the outermost shell here, which is the last shell, I'm calling outermost shell. If I'm to draw this, I'll be having this. This is my nucleus. I'll be having 2 electrons, and then I'll be having 1, 2, 3, 4, 5, 6, 7, and then 8. You can see that the outermost shell here, it has 8 electrons. So don't forget, I said for an electron, for an element to be stable, it must have either octet or duplet configuration. So this one has octet. Octet means 8 and duplet means 2. This one has octet, which means it has 8 electrons in the outermost shell, in its last shell. That's why its valency is what? 0. So other elements are unstable. For example, let's look at chlorine. Chlorine is number 17. If we have to draw that of chlorine, it will be chlorine here. This is the symbol for chlorine, Cl, right? It will be 2, 8, 7. That's 2 plus 8, 10 plus 7 17. You can see this one is what is 7. It is not 8. That means it still needs one more electron to obtain a duplet or octet configuration. So here, this one is unstable. For it to be stable, it has to combine with another element. Am I communicating? That's why we have chemical combination. They combine elements that are unstable, combine with one another to form what? To form a compound. Am I communicating? Yeah, now we can say, if you have to write something, you can write now. A chemical bond, we have, from chemical combination, we have what we call chemical bond. And a chemical bond is the cohesive force between atoms when they combine chemically. A cohesive force between chemical atoms when they combine chemically. That is, the reason, we have two types of force. We have, some are adhesive, some are cohesive. When we say cohesive, it is cohesive means forces that hold the same molecules together. So a chemical bond is a cohesive force. Are you guys with me? A chemical bond is a cohesive force between atoms when they combine chemically. That's what we call a chemical bond. You can write from there. Okay, from here now, let me explain what we call valence electron, the octet rule. The octet rule. Valence electron, the octet rule. This is just a bit of explanation of what we call chemical combination. The reason why we must have chemical combination. Elements, when they ask you why those chemical combination occur, the reason why we have chemical combination is because element has to unstable element has to combine with one another to become what? Stable. That's chemical combination. Okay? From there, we have the valence electron. I'll be explaining the octet rule. Valence electron, or let's just call it the octet. Here it is the octet rule. Octet rule. The octet rule. Now, what are valence electron? You can say valence electron is the number of electrons in the outermost shell of an element. You are right. You can say a valence electron is the number of electrons required by an element to obtain an octet or duplet configuration. You are right as well. Am I communicating? And you can say a valence electron is the number of that's if you are talking about a positively charged element. This definition I'm about to give. If it is a positively charged element, you can say a valence electron is the number of electrons that can be donated or that a metal can donate to become ionized. For example, sodium. Sodium can donate 1 electron. That means its valence electron is what? 1. That's why you can see when we're talking of ionized form of sodium, we do write Na+. So if it is for a negative element that you're talking about, we can say a valence electron is the number of electrons that can be accepted by that electron to form an octet or duplet configuration. For example, if you look at chlorine, I said earlier that chlorine is 287. We can see that here 7 it remains 1 electron for it to obtain octet configuration. So the ionized form of chlorine is what? Cl-. That's why we have Cl- there. Are you guys with me? Okay. Now, I've explained what valency means, right? And as well, I thought you guys should have been, that should be the first time we're going to explain how we can derive the valence of an element. For the first 20, we have to derive the valence of an element. Some, you can say their valence is their last number for metals. For some, we say we subtract, we look for the number of elements for non-metals rather. If it is metal, their last number of electron is the valence electron. If it is non-metal, the number of elements required to become octet or duplet will be their valence electron. What I'm trying to say in short form is this: to get the valency of sodium, sodium is what? Number 11. From hydrogen, helium, lithium, sodium is number 11. So this is 281. It is metal. The valence electron is 1. Aluminium is number 13, 283. It is 3. The valence electron is 3. For chlorine, chlorine is a non-metal. This is Cl. Chlorine is number 17. That's 287. Because here it is 7, it is a non-metal. To go to non-metal, how many numbers? Local for that 8. 1. Valence electron might get 1. But because it's a non-metal, we say the valence is what? Valence number minus 1. Because this one is a metal, we say it is what? Plus 1. This also is a metal, we say it is what? Plus 3. Another way by which you can get valence electron is that what? Is this. If the last number is greater than 3 or equal to 4. If this last number is greater, okay, let's say if the last number is greater than or equal to 4, subtract 8 from it. If the last number is greater or equals to 4, subtract 8 from it. For example, you can see this one is greater than 4. Subtract 8 from it. 7 minus 8, that's minus 1. Let's look at carbon hydrogen, fluorine. Let's look at fluorine. If you look at fluorine, fluorine is number 9. That's 27 as well. It is greater than 4. I will subtract 8 from it. 7 minus 8, that's minus 1 as well. Right? Let's look at nitrogen. Nitrogen is number what? Nitrogen is number 7, right? Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. Nitrogen is number 7. So number 7, nitrogen is number 7. That's 2, 5. Subtract 8 from it. That means the valence of nitrogen can be what? Minus 3. I'm not saying you subtract it from it, or subtract 8 from it. Let's look at oxygen. Oxygen is number 8. So that's 2, 6. Am I communicating? So if it is 2, 6, since 6 is the last number here, it's greater than 4, subtract 8 from it. 6 minus 8, that's minus 2. That's another way by which you can get the valency of an element. And please write down the definition of valency I defined earlier. I said, we can as well say, a valence electron is the electron in an incomplete filled outer shell of an atom. We can say that as well. A valence electron is an electron in the incomplete filled outer shell of an element or of an atom. A valence electron is an electron in the incomplete filled outer shell of an atom. That's a valence electron. At the same time, valence electron is it can also be, you can say valence electron, valence electron is the number of electron in the outermost shell, of an atom. That's another definition of a valence electron. You can as well say a valence electron of an atom. You can as well say a valence electron of an atom is equal to the charge carried by an ion of the atom. That's another definition. Any of the definition you just decide to use, you are correct. Any of the definition you decide to use, you are right. You are very, very right. This is a valence electron. Just pick one and you're good to go. You're good with it. So yeah, now here. Now, you know, I said earlier when I was explaining chemical combination that atoms of a stable element have to combine with one another, right, to form a compound. Now, during chemical combination, the valence electron of some element has to be transferred. A valence electron can either be transferred, it can be shared. Am I communicating? It can be transferred, it can be shared. And if it is transferred, that means it's going from one atom, that's electropositive, to the one that is electronegative. It can be shared. When it is being shared, it means two parties are donating equal amount of electron, and when those shared electron is being donated by just one atom, we call it a lone pair. So I'll be talking about types of chemical bonds. You will understand better when we're talking of type of chemical bond. But for here, we're just doing the introductory parts, and I'm picking them one after the other. So for easier understanding, that's that about that. Okay, now, before a chemical combination can occur, valence electron have to be transferred. That is, for example, sodium is number 11281. Before we totally obtain octet configuration, we want to transfer electron. I transfer one to who? C element to have combined value. So some elements can only accept, they can't donate. While some elements can donate and they can't accept. That brings us to what we call the octet rule. Now, the octet rule states that, you can write, the octet rule states that an atom continue to lose, an atom continue to lose, gain or share electron in order to have 8 electron in the outermost shell. An atom continue to lose, gain or share electron in order to have 8 electron in the outermost shell. Are you guys with me? That is, atom, before they can be stable, they have to obtain what? I believe you guys said 8 or 2. Abi, that's octet or duplet. So now they must have octet configuration or duplet configuration. So octet rule here was of an atom 80 over 80, you lose. To bá jẹ́ pé o lè lose, to bá jẹ́ metal ni you lose, to bá jẹ́ non metal ni you gain. For example, sodium is a metal, chlorine is a non metal. Sodium is 281, chlorine is 287. Kí lè bá lè react pẹ̀lú eléyìí wá lose ẹyọ kan yẹn, òun ó pé 8 28. Ẹni pé ó ti balance, ó ti ní 8 padà bí. Eléyìí wá pé kí ni, eléyìí náà add mọ́ bí, wọ́n yìí yóò add mọ́ bí, eléyìí máa lè 288. Ẹni pé eléyìí náà ti pé 8 yẹn padà. So it will lose or gain. This one lose, while this gain. Or continue to share electron to obtain 8 electron in the outermost shell or in the electronic configuration. Okay, it states an atom continues to lose, gain or share electron in order to have 8 electron in the outermost shell. Yeah. Now you can understand this brief explanation about the periodic table. Here you can write another paragraph. The atoms of elements in the same group in the periodic table. The atoms of elements in the same group in the periodic table, an isotope of an element, undergo the same type of chemical combination and have similar chemical properties. Yeah. The atoms of elements in the same group in the periodic table and isotopes of elements undergo the same type of chemical combination. Since they have the same number of valence electron. If we are talking of the periodic table has rows and columns. We have rows and columns in the periodic table. So groups are elements that are in the same column, vertical column, in the same column. An element in the same column have the same chemical properties. Also, isotopes of an element have the same chemical properties. Chlorine has isotopes, 2 isotopes. Oxygen has 3 isotopes. Hydrogen has 3 isotopes. So some element has isotopes, and I believe we all know what isotope means. Element that have the same words, the same atomic number but different mass number, or element that have the same number of protons and different number of neutrons. Thank you. So when it is isotope, they are going to have the same chemical property because they have the same valency. You know, the atomic number will be the same, but what will be different is the mass number. What will be different will be the mass number. So the atomic number will be the same. Since the atomic number is the same, an atomic number is used to determine the electronic configuration. As their electronic configuration is the same, they will have the same valence, and hence they will have the same chemical properties. Okay, now let's talk about types of chemical combination. Types of chemical combination. Types of chemical combination. Now, the four main types of chemical combination are one, we have electrovalent or ionic. Electrovalent or ionic. Electrovalent or ionic. Two, we have covalent. Three, we have coordinate covalent. Covalent or dative. We're not going to call it dative. We call it dative. And four, we have metallic. Those are the four main types of chemical combination: electrovalent or ionic, covalent, coordinate covalent, and then we have what? Metallic. So what we're doing now is what? We're picking them one after the other. It might not be once, we'll not do everything once, so that you guys will have a better understanding of it. Just know we're doing it one after the other. So the first one we're talking about is what? Electrovalent combination. Now, right, electrovalent combination. Now, right, in an electrovalent or ionic bonding, one thing you have to understand is in electrovalent combination, the type of bond that we have there is what? Electrovalent bond or ionic bond. In covalent combination, the type of bond we have there is what? Covalent bond. In coordinate covalent combination, the type of bond we have there is what? Coordinate covalent bond or dative bond. In metallic combination, the type of bond we have there is what? Metallic bond. So please take note of that. Now, we're on electrovalent. Let's talk about electrovalent combination. Now, in an electrovalent or ionic bonding, there is complete transfer of all the valence electron of a metal atom. There is complete transfer of all the valence electron of a metal atom to the valence shell of a non-metal atom. There is complete transfer of all the valence electron of a metal atom to the valence shell of a non-metal atom, so that each atom acquires a stable noble gas electronic configuration. So that each atom acquires a stable noble gas electronic configuration. Just like I said earlier, when I was explaining, I used an example using sodium and chlorine. There is a complete transfer of valence electron from a metal, am I communicating, to the valence shell of a non-metal. Complete transfer. That's why I use the word complete. There is a complete transfer. Just have a look at this. When I was explaining this earlier, when I said sodium and chlorine, we all know this one is a metal. Why this is a non-metal? Am I communicating? This one is 281. This one is 287. This is the outermost electron, valence electron. There is now going to be a complete transfer of this to this. This will be transferred to this, so that they both have an octet configuration. They both have 8 electrons. Element 28. Element 288. So in a situation whereby whenever you are given any compound and you see that you're having a metal and a non-metal, what should come to your brain should be what? This type of combination is what? Electrovalent combination. And the type of bond that exists between them is a what? Is a ionic or electrovalent bond. I've explained what chemical bond means. I mean, what I said chemical bond is, go back to your notes. I said chemical bond is what? The cohesive force. The cohesive force that holds the atoms together when they directly in a chemical combination. Just go back to your notes and see that. Go back to your notes. I said the cohesive force, right, between atoms when they directly combine chemically. I think that was what I said earlier. Yeah. I don't want to state a different definition for that. A cohesive force that holds atom when they combine chemically is known as what? Chemical bond. Yeah, that's chemical bond. Just know that it is a force. Chemical bond is a force. Kí nǹkan tó lè stick papọ̀, ó túmọ̀ sí pé ó gbọ́dọ̀ ní nǹkan tó dì wọ́n mú. So in tó dì wọ́n mú yẹn là ń pè ní chemical bond. I thought you guys should know what we call a force. That's in your physics. Yeah. But what we have here in chemistry is kinetics, kinematics. So that's what we're talking about, like get it and go. Okay, let's continue. I've explained what electrovalence is. Now, whenever you see that we're having a metal and a non-metal, what should come to your brain is what? Electrovalent or ionic bond. That is, there should be a complete transfer of valence electron. I'm only using sodium and chlorine as an example. We don't only have sodium and chlorine. Am I communicating? We don't have what? Sodium and chlorine. It can be aluminum and oxygen. Al, aluminum and oxygen. You know, oxygen is diatomic in nature. O2. It can be aluminum and oxygen. Am I communicating? As far as this is a metal and this is a non-metal, it can be aluminum and oxygen. It can be magnesium and chlorine. It can be magnesium and fluorine. It can be hydrogen and iodine. You know, hydrogen can react in two phases. Hydrogen can lose electron. When hydrogen loses electron, it is known as hydrogen ion. You can put that at the back of your notes. When hydrogen loses electron, it is known as hydrogen ion. And if hydrogen lose electron, hydrogen can only lose electron when it is reacting with a non-metal. That's one of the properties of hydrogen. Hydrogen can act as a metal and can act as a non-metal. But when it is acting with a non-metal, it's going to lose electron to that non-metal. But when hydrogen is reacting with a metal, note the type of metal that hydrogen can react with are metal that are more reactive than it. Metals that are what? That are more reactive than it. For example, sodium, magnesium, aluminum, calcium, zinc, iron. Those are metals that are more reactive than hydrogen. So when hydrogen reacts with metals, it's going to gain electrons. It's not going to lose there. It will gain. And when it's gained, it's going to form what? Hydride. When hydrogen loses electron, it becomes hydrogen ion. When hydrogen gains electron, it becomes hydride. So that's why when hydrogen reacts with probably, let's say, calcium. To name that compound, we call it calcium hydride. So just know that. You can just add that at the back of your notes. Now, let's talk about formation of ion. I want to explain the valency of an element. I think I should just briefly explain that so that you guys will get to understand what we are trying to say here fully. Let's talk about formation of ion. It's also, we are still under electrovalent or ionic combination. So the next thing is subtopic formation of ion. Then put hyphen. Formation of ion, put hyphen. Valency of an element. Formation of ion, valency of an element. Now write. Normally, right. An atom is electrically neutral. An atom is electrically neutral. Right? Now, when it loses or gains one or more electron, when it loses or gains one or more electron, it becomes an ion. An atom is electrically neutral. When it loses or gains one or more electron, it becomes an ion. Full stop. An atom that loses one or more of its valence electron, an atom that loses one or more of its valence electron form a positive ion. Èyí tó bá ti lose, ó la sọ pé metal nìkan ló máa lose. That's when they ask you to define metal. You define a metal as an element that ionizes by losing electron. So when it loses, it becomes a what? Positive ion. An atom that loses one or more electron is what? A positive ion, charged ion. We call them cations. cations. Where's my marker? An atom that loses one or more ion forms a positively charged ion called cations. Cations. The full meaning of this cation means cations. It means cathode ions. Cations. It means cathode ions. That's cations. Okay? While an atom that gains one or more electron, an atom that gains one or more electron form a negatively charged ion called anions. And the full meaning of these anions, it is just a short form of what we call anode ions. Cations and then anions. Cations, cathode ions. Anions, cathode ion. Am I communicating? What I'm trying to say here is that, for example, when you're having sodium, Na. Okay, I've been using sodium since morning. You guys shouldn't be like, why is it only sodium? Sodium. Let's change it so that you guys will understand better. Let's look at this. What's on your mind? Probably let's use calcium. Okay, calcium. Let's say calcium. This calcium that I'm having here is a neutral atom. Calcium is what? Number 20. Hydrogen, helium, lithium, boron. Calcium is number 20. Am I communicating? It is a neutral atom. Now, because it is a neutral atom here, we don't feel anything. One feel plus, one feel plus, one plus, one minus. It means it is a what? Neutral atom. So here you can see it is number 20. Since it's a neutral atom here, this means here that calcium, because it is neutral, calcium has 20 proton and 20 electron. The ion. But calcium is electropositive because the last number of electron, Tabaya 2882, is 2. So it will lose it. Calcium is electropositive. So when it loses that electron, if you check your note, I said when it loses or gain one or more electrons, it becomes an ion. So when calcium loses electron, Ca2+, it is no more a neutral atom. We call this one calcium normally, but this one we call this one calcium ion. This will become calcium ion. It is not calcium again. It's going to be what? Calcium ion. And the difference between this and this is that, here this one has 20 proton. The number of proton will still be the same because when it loses electron, it does not affect its nucleus. It does not affect its nucleotides. But yeah, we are still going to have 20 protons. But number of electrons will be affected. When it is 2+, it means it has lost 2 electrons. So 20 minus 2, that is going to have 18 electrons left. Let's look at oxygen. Oxygen. This one is an atom of oxygen. It is an atom, neutral atom of oxygen. No plus, no minus. It's a neutral atom of oxygen. And oxygen is number what? Oxygen is number 8. This means here that oxygen has what? 8 proton and 8 electron. 8 proton and 8 electron. That's what oxygen has. Now, but when oxygen gain electron, O2 minus, this means it has gained electron. We don't call this oxygen. This is what? Oxygen ion. So if this is oxygen ion, it is still going to have the same number of proton, 8 proton. But because the number of electron has what? Has increased. It has gained electron. The number of electron now will be different because it is now an ion. It has gained. So this becomes what? 2 minus. What the rest must be able to gain in Meiji. For example, Cl minus. Cl minus means it's gained 1. N3 minus means it's gained 3. But this one is O2 minus means it has gained 2. So this becomes 10 electron. Am I communicating? So that's the difference between a neutral atom and an ion. Okay, let's write this down, another paragraph. In an ion, I'm trying to give you a note of what I just explained. In an ion, the number of protons in the nucleus. In an ion, the number of protons in the nucleus is no more equal to the number of orbiting electron. Is no more equal to the number of orbiting electron. Full stop. Hence, is no more equal to the number of orbiting electron. Hence, an ion is not electrically neutral. That's why it is charged. An ion is not electrically neutral. That's why it is charged. Yeah, now, but it's what to the ion or equal. But to get neutral atom or equal. Must have in neutral. Or neutral. It doesn't have any charge. We have plus in there, minus. But to what to pay what it gain. Normally, electron is negatively charged. You must have been thought of that. Proton is what? Positively charged. That's minus 10 plus 8 minus 2. Don't need 2 minus in by. They are no more equal to what the ion 1 equal more. Elate to the 8, elate to the 10. To what will be by now 1 equal more. Elate to the 20, elate to the 18. If it is an ion, it will no more be what? Be equal. It will no more be equal. Now let's look at this. Generally, another paragraph. Atoms of elements in group 1, 2, and 3. Group 1, 2, and 3 usually lose their valence electron in order to form the most stable cation with noble gas configuration. Group 1, 2, and 3 usually lose all their valence electron. Yes, they will lose all their valence electron. I'll give you an example of such element that we're talking about. They usually when I was explaining electrovalence, I've mentioned sodium, I've mentioned aluminum, and here I'm mentioning calcium. Usually lose all their valence electron in order to form the most stable cation with noble gas configuration. Full stop. They are metals. That's how we know metals. They will lose all their valence electron. Example, we have sodium, Na. Sodium is a metal. We have silver, Ag, argentum. We have copper. Those are metals. We have magnesium. We have potassium. We have calcium. Those are what? Metals. We have iron. We have zinc. Those are what? Metals. We have lead. We have tin. They are metal. Those are examples of metals. Those are examples of what? Of metals. I hope you guys are with me. So we know that when an element loses, it is what? A metal. Now, continuation. Atoms of elements in group 5, 6, and 7 in the periodic table gain elements to form anion with noble gas structure. Atoms of elements in group 5, 6, and 7 in the periodic table gain electrons to form anions with noble gas electron. They are non-metals. They are what? Non-metals. That is, you are going to form octet configuration when they gain electron. Example, I've been stating one since morning. I stated chlorine is an example. Oxygen is an example. Nitrogen is an example. Are you guys with me? Fluorine is an example. Iodine is an example. Bromine is an example. I've stated oxygen earlier is an example. Those are examples of what? Non-metals. They are non-metals. Now write this down. Note this. Note. 1. The charge of an ion is the electrovalency of the element. The charge, that was a charge. Charge is too much. element mélòó ni atom electron mélòó ni atom lè lose àbí ló lè gain. The number of electrons an atom can lose or gain is what we call it charge. Now a charge, you know, some questions will not, for example, some WAEC questions now, they won't tell you what is the charge, they'll tell you what is the electrovalency of so. That's what they'll tell you. So one, the charge of an ion is the electrovalency of the element. For example, sodium, they said, what is the electrovalency of sodium? Na now. I don't know, but sodium can only lose one electron. It means its electrovalency is what? 1. Calcium can only lose 2 electrons. It means the electrovalency is what? 2. Okay, the charge of an ion is the electrovalency of the element. That's 1. 2, atoms of elements in the same group form identical ions. Atoms of elements in the same group form identical ions. That was when you will understand that much more better when we are dealing with periodic table. Elements in the same group have the same chemical properties. That is why they also have the same valency. Because they have the same valency, they have the same chemical properties. That's number 2. Atoms of elements in the same group form identical ions. For example, sodium and potassium are in the same group. With silver as well, they are in the same group. That's why sodium, potassium, and silver are in group 1 of the periodic table, because they can only lose 1 electron. If you check your periodic table, you will see sodium in a single line. You will see them in a single line. That's why chlorine, fluorine, iodine, bromine, and astatine are also in the same group, because they can accept just 1 electron. Are you guys with me? That's also the same reason why calcium and magnesium are also in the same group, because they can lose 2 electrons. So elements that can lose 1 electron are what we call group 1 elements. That is, they have a valency of 1. Group 2, they can lose 2 electrons. They have a valency of 2. That's why we call them group 2 elements. You understand that better when we are moving on to periodic table. Number 3 here. Number 3. An atom of element in group 4 and O do not gain or lose electron. And atoms of elements in group 4 and O, 0, that's group 0, does not gain or lose electron, because they are going for group 4. Group 4 element is going to use all their valence electron to form what we call bonds. They form what we call what? What we call bonds. That's what they are going to form. So they don't lose or gain electron. That one is, those are the notes I'll be giving. Now let's solve this question. Let's look at this question. Let's solve it literally here now. Number 1 here. It said the atom and ion of sodium have the same what? You know what I was explaining? Look at this. An atom and ion is going to have the same number of what? Eléyìí ní 8 proton. Nígbà tí kò tí gain rárá, this oxygen, you can have oxygen as example, but sodium no bearing no question. Let's oxygen as an example. Eléyìí ní 8 proton bí báyìí, but tí ó ti gain kò tí lose. Eléyìí náà ní 8 proton bí báyìí, kò tí gain kò tí lose. Eléyìí ní 8 electron. But again, ó di 10 electron. So between proton and electron, which one will be equal? Here we are given option now. And an atom and ion of sodium, we have the same what? Number 1, they said chemical properties. Number 2, they said they have the same chemical electric charge. 3, they said electronic configuration. And 4, they said number of proton. Kí ni ó change the number tẹ́lẹ̀ yìí gain? Proton you change. That means that we have the same number of proton. That will be your answer. It is a NECO question. Let's solve this WAEC question as well. This WAEC question says that if the mass of X, please write down all this question I'm telling you guys. If I should come, your note, and this thing is not your note, we'll fight. If the mass number of X is 24, if the mass number of X is 24, if the mass number of X is 24, that is mass number X3, mass number is 24, mass number of X is 24, and X2 plus contain 10 electron. X2 plus contain 10 electron. X2 plus contain 10 electron. The nucleus of X will contain what? You know, in the nucleus we have just two things, proton and neutrons. The nucleus of X will contain what? A, 8 proton and 16 neutrons. B, 10 proton and 15 neutrons. C, 10 protons and 12 neutrons. D, 12 protons and 12 neutrons. A, 8 proton and 16 neutron. B, 10 proton and 15 neutron. C, A, 8p, 8 proton and then 16 neutron. B, 10 proton and then 15 neutron. C, 10 proton and then 12 neutron. And then D, 12 proton and then 12 neutron. How can we get the answer for this? Let's look at this. They said X2 plus. I told you earlier, whenever we see charge, it has become an ion. But our plus lórí, almost is what? A metal. A metal is the one that forms positive charge. And the metal will a metal lose again? I believe you guys said it is going to what? It's going to lose. It's going to lose. Now, before we can get the number of proton and neutron, let's turn this back to a neutral atom. So to bá jẹ́ neutral atom, mo ní sure bó ti lose already, ó tún wá sí pé ó gbọ́dọ̀ gain nǹkan tó lose padà. Tó bá máa gain nǹkan tó lose padà, that two tó ti lose yẹn máa add papọ̀ mọ́ 10. Tó tún wá sí pé electron is going to be what? It's going to be what? 12. 10 plus 2, 12. And don't forget I said earlier, a neutral atom is going to have equal number of proton and equal number of electron. That means if electron is 12, proton also will be 12. Ẹ jẹ́ ká wo èwo ló ní 12 proton bí báyìí. 12 proton. Option D ló ní 12 proton. Okay. Ẹ jẹ́ ká wá wo number of neutron. Don't forget that mass number equals proton plus neutron. Abi, if proton is 12 now, and our mass number is 24, that means 24 equals proton plus neutron. The neutron number will be what? 24 minus 12, that's 12. Obviously, we're having 12 proton and 12 neutron. That means our answer here is option D. I hope you guys are with me.